Okay, this is the formula to compute the sum of the geometric sequence. S sub m is the sum of the first element in the geometric sequence is equal to the first one, a1, parenthesis 1 minus r to the n power divided by 1 minus r. Let's see example. Look, in this example, I can see the common ratio of this geometric sequence, u divided by 1 over 4 divided by 1 half is 1 half. And the first one is 1 half, no? That's the coincidence, 1 half, 1 half. So the sum for any element is equal 1 half 1 minus 1 half square no, to the n power divided by 1 minus 1 half. Okay, 1 minus 1 half minus 1 minus 1 half is 1 half, and 1 half and 1 half is cancelled, and the answer is 1 minus 1 over 2 to the n power, because 1 to the n power is 1 and 2 to the n power is 2 to the n. This is the formula. Suppose I want to verification that this formula is good or not. Let's do it, for example, one elementary example. Let's do one elementary example. Suppose okay, that part only. Okay, suppose compute S3 is the sum of the first 3 elements here, this and this. We can do by hand, of course, but we're using the formula 1 minus 1 over 2 to the third power, because n is 3. 1 minus 1 over 8 is 7 over 8. So you are doing by hand, know the formula 1 half plus 1 over 4 plus 1 over 8. The least common denominator is 8. 8 divided by 2 is 4 times 1 is 4. 8 divided by 4 is 2 times 1 is 2. And 8 here is 1 over 8. You add in this is 7 over 8, exactly the same answer. The formula is perfect. Okay, now we suppose series. What is series? Series infinity summation. So suppose S of m is summation, no? From k equal 1 to the m, in this case k here, to the a1 r to the k minus 1. K is the index variable, but s is a limit. When the n approaches infinity, you consider that the number of elements is infinity of the s bar. And remember, the formula for this is a1 minus r m divided by 1 minus r. To compute that limit, when the approach to infinity, you separate this into pieces. So S sub m is a1 over 1 minus r minus a1 r sub m over 1 minus r. And you apply the limit. You apply the limit when this approaches to infinity. This is just a number, do not depending of it. Therefore, it stays the same. This limit, no. This part change. But it change depending if absolute value r is less than 1. So this common ratio is less than 1. This part, when your n approaches to infinity, go to 0. And s is equal a1 1 minus r. When this situation happens, that's, you can say that the series is convergent. Okay, so the condition to converge is that the absolute value of the ratio is less than 1. But the ratio is less than 1. 1 half, negative 1 half, negative 1/4. Otherwise, it's divergent. And do not converge it to any number. Let's see example now. Okay, prove that this series is convergent. Try to find what value converges this series. Okay, you analyze this term. A sub m is 1/2 raised to the n power. Generally, this is a1 r n minus 1. Now this is equivalent to say 1/2 times 1/2 raised to the n minus 1 equal a1 r to the n minus 1. In this case, we have a coincidence that a1 is 1/2 and common ratio is 1/2. Okay, so the condition is necessary to satisfy in order to be convergent is the actual value ratio is less than 1. Actual value 1/2 is obviously 1/2 is less than 1. Therefore, the series converges. But converge at what value? This is the formula for the value for the a1, 1 minus r. a1 1/2 is a coincidence. 1 minus r is 1/2. 1 minus 1/2 is 1/2. If 1/2 divided by 1/2, the answer is 1. This series converges to 1. It's like this. Okay, number 1 is determine C if this series is geometric or not. You divide 4/3 divided by 2. 4/3 times 1/2. Simplification here is 2/3. Okay, we're checking this and this. 8/9 divided by 4/3. 8/9 times, flip it, 3/4. Divided by 3, 1, divided by 3, 3, divided by 4, 1, divided by 4, 2, 2/3. Good. Confirmation. Common ratio is 2/3. 2/3 is less than 1. Therefore, this series converges. Convert at what value? At the value S is equal a1, 1 minus r. a1 is 2 in our example, the first one. And 2/3, we determine this, r, sorry, 2/3, minus 2/3. 2/1 minus 2/3 is 1/3. Flip it, 2/1 times 3/1. The answer is 6. 6 is the value that this series converges.